So let f of x be this function, and let's find all the horizontal asymptotes of this function. Now, I'm going to give you a few minutes to work on this, but let's kind of sketch out what we are going to be doing. So first of all, you need to ask yourself, how do I find the horizontal asymptotes of a function? Right, in general, right? Doesn't matter what the function is. Can you answer that question in general? You don't have to answer in chat. I'm just asking. This is kind of rhetorical. If you were given any function, what should you be doing, right? Right? How should you be starting that? And if you're unsure of how to start that, right? What do? You have to go back and look at, well, didn't Dr. G tell us what a horizontal asymptote is? Yes. Right here. I told you what a horizontal asymptote is. Right? So you can find the answer for yourself. How do you find a horizontal asymptote? Okay, now once you do that, now it's going to be very helpful for you to know what happens to e to the x, right? So you might need to know what is a graph of e to the x. That'll probably be very helpful. And then finally, try to compute the horizontal asymptotes from that. So I'm going to give you a few minutes to do as much of this as you can. So let's say, I'll give you a good amount of time. Let's say 5 minutes. Again, you may not necessarily finish the problem, but try to at least answer, as much of these questions as you can. I know not everyone works as fast. I know that are not all experts at this quite just yet. Anyone else hate emails now? I hate every email I get. Like, no, Raj, your email does not find me well. And I could really go for like some precedented times right now, just so you're aware. So first of all, the first question was horizontal asymptotes. How do I compute the horizontal asymptotes of any function? So forget about this function. How do I compute the horizontal asymptotes of any function? How did you answer that first question? Let's see. Should I ask someone on camera or should I ask a random person in the chat? Okay, Nicole. Factor out the highest power, factor out highest power. So it seems we're all kind of skipping a step here. First of all, this function doesn't have highest powers, and general functions don't have highest powers. Take limit from both sides. What do you mean from both sides, Jessica? Okay, I think Esha has finally gotten it. Esha or Isha, I'm sorry if I said your name wrong. Infinity and negative infinity. Okay, so that's good. So if I want to calculate the horizontal asymptotes, there are two limits I calculate. Right, I need to calculate the limit as x goes to infinity of the whatever function we have, and the limit as x goes to negative infinity of whatever function we have. Now, then what, say some other people in chat were saying, factor out highest powers, whatever, then that's the actual particular strategy for computing those limits. But at a fundamental level, horizontal asymptotes go hand in hand with limits as x goes to infinity and as x goes to negative infinity. That's what you meant? Well, that's not what you said, Jessica. But yeah, I knew that's what you meant. But we want to always be precise. Okay, now in this particular case, it's probably going to be useful to know what happens to e to the x. Now, you said you factor out e to the x. It's actually going to turn out that you factor out different things depending on which limit you're talking about. And why is that? Well, because e to the x is kind of a very funny function. Let's recall two graphs that you should absolutely know. We're looking at y equals e to the x and y equals e to the negative x. So what does y equals e to the x look like? There you go. That's it. What does y equals e to the negative x look like? What's the relationship between these two graphs? So I have replaced x with negative x. So how does that affect the graph? Flip. Well, there's a bunch of ways I can flip it, Caleb. So can we be more specific about how we flip the graph? Shouldn't it be negative e to x? Well, negative e to x would be a whole different function, but I want e to the negative x. I don't want negative e to the x. I want this. Let's see, reflection over the x-axis. Not quite. If I did reflection over the x-axis, that would be all the y values have now become negative. So that would be y equals negative e to the x, right? All the y values have become negative, but all the x values have kind of switched. So that means we actually reflect in the y-axis, right? They actually need to give a reflection tool in this, unless it's already here and I don't know. Okay. Now, given these graphs, let's look at the following limits. So what happens as x goes to infinity of e to the x? What happens as x goes to negative infinity? And the same thing over here. X going to infinity, x going to negative infinity. So, first limit. As x goes to infinity, what happens to e to the x? Right? How would you just get that from the graph? Well, if x is going to infinity, I'm going all the way to the right, right? Arbitrarily far to the right. And what happens to all the corresponding y values? They just keep going up and they get arbitrarily large, right? So they approach infinity. Good. Now, what happens as x goes to negative infinity? So what happens? I trace the x values to the left and I look at the corresponding y values, right? They all approach zero, right? The y coordinates actually approach zero. Now, what happens with e to the negative x? The two limits reverse, right? Now for e to the negative x, as x goes to infinity, I get zero. As x goes to negative infinity, I get infinity, right? So it's opposite. Now, this is very, very important. The fact that e to the x has different behavior at the two infinities, that kind of crucially affects how you compute asymptotes with e to the x, right? Because on one end, towards the right, e to the x gets huge, arbitrarily large. But on the other end, e to the x goes to zero, gets arbitrarily small. So on one end, it's getting big. On the other end, it's getting small, right? Totally different behaviors. So that's going to affect how we actually compute these limits. So now let's look at the limits. Okay, so let's look at, let's go x going to negative infinity first. Let's see, what was our function? Our function was 3 plus e to the x over 5 minus 4 e to the x. Okay, good. Let's try to keep this. Okay, so let's try to keep the special limits on the screen at the same time. Okay, so what are you thinking here? So let's do the negative infinity limit first. What are you thinking for this? What strategy are we using? Are we factoring out? Are we doing something else? What are we doing here? It might be kind of useful to know, well, what happens to each term, right? Don't be in a rush to factor out, because I saw a few people earlier say, oh, I factored out the e to the x. But the strategy was really factor out highest power. In other words, factor out the biggest term. Is e to the x actually the biggest term? And that's actually the trick here. E to the x is not the biggest term. Why? Remind me, e to the x, as x goes to negative infinity, what happens to e to the x? It goes to zero. So actually, these constants are actually the biggest terms, because the e to the x is going to zero and the constants just stay constant. So if you factored out the e to the x for this limit, the negative infinity limit, that's not the correct strategy, right? The correct strategy here is actually even simpler. There's no factoring at all is required. I already know that these two terms, the limit is just zero, right? X going to negative infinity of e to the x, that's just zero. So altogether, I can just say that this limit is 3 plus 0 over 5 minus 0. The limit is 3 over 5, all done, right? There's no advanced strategy at all there. That's really just knowing what happens to e to the x. That's it. Now, what happens as x goes to positive infinity? Now, that we know is already going to be different, right? Because if x is going to positive infinity, we know that e to the x goes to positive infinity, right? It has a different behavior depending on which infinity you're going to. Now we can factor out highest powers, because now we can say, aha, these terms, the e to the x terms, they go to plus infinity. So they get huge compared to the constants. So that's where we would now factor out the e to the x. Okay, so when I factor out e to the x, let's see, what do I get? I get 3 e to the negative x plus 1 all over 5 e to the negative x minus 4. And I'll just have to go about a few seconds over if you just let me. The e to the x's that I factored out cancel, which is great. And now I'm left with e to the negative x's instead. And I know from what I just did before a few minutes ago, aha, these actually have limit 0. Right, that was another one of those special limits that I wrote down with those graphs. And so now I can say, okay, I have 0 plus 1 over 0 minus 4. So I get negative 1 over 4 as my limit, and then I'm all done. So just to kind of finish it up, so the horizontal asymptotes are y equals 3 over 5 and y equals negative 1 over 4. So I apologize that I went about a minute over. Sorry about that. But that is all for today. If you have questions, stick around. I also have office hours today. Infinity over infinity is actually another one of these undefined expressions. It's like a 0 over 0, actually. So infinity over infinity is also undefined, except the limit can be anything. So infinity over infinity suggests to you there might be algebra, there might be cancellation. It can be anything you want. Office hours are 1:30 to 2:30. How would you know to use y equals e to the negative x along y equals e to the x? Well, they're right in the function, right? The original function had e to the x, so it made sense that I was probably going to have to examine what happens to e to the x, right? I should know what happens to e to the x. The reason why I looked at e to the negative x is actually because 1 over e to the x is e to the negative x. And I know that when I do limits with infinity, reciprocals are also important. So not only should I know what e to the x does, I should also know what its reciprocal does, which is the same thing as e to the negative x.